let's do the UVs for our wall. So put down an attribute promote. So we can promote our part type to a primitive. And then we want to blast away everything that's not our wall panels here. So delete non-selected, at part type equals wall. And then we need a divide. Turn off convex. Turn on breccia. And let's switch this to 20 in Y. And then it's hitting escape to cancel it while it's trying to cook. In our X and Z, we want something like ridiculously high, because we don't actually want, we only want to divide it in Y. Cool, so that's added these vertical divides for us. It's going to do a fuse to make sure as much is connected as possible. Do a clean. Just because these wall panels are probably going to be the worst geometry we have. They also have the messiest UVs, but it's a losing battle to try and get them to have perfect UVs. Okay. Now we need a wrangle. Because you need to divide these into vertical sections. So I'm going to run over primitives, and then the first thing we need to do is get all the points attached to each primitive, which we can get by using this prim points expression. And that just wants the op input, which is 0, and the primitive we want to get the points from, which is our prim num. Then I'm just going to initialize a float called y, because then we're going to loop over with a for each. And loop over every single each point we grab from our prim points. And then get the position of that point we're currently on. And then go y plus equal the y of the point. And then we take y, and when that's going to be now equal to y divided by the length of our point array. So how many points there was, and that'll give us our average y value. And let's just store that as an attribute. And store it as a vert ID. And to do that, we're going to use a rint. And the reason I'm putting the rint in this int is just so Houdini doesn't, it'll yell at you saying it's not actually a proper integer. Cool. So y divided by 20, which is our division scale. And then I'm just going to do plus 0.5, like 0.05. Just so a little bit of tolerance in there. Oops. And then let's check to see if this has worked. Put down a color. Do a primitive color. Random from attribute. And see if we can find our... It's not showing up there, so let's type it in. Vert ID. And delete existing colors. And there you go. You can see these are our vertical sections. Okay. Now we need another angle because we need to get horizontal sections. Okay. This is also going to run over primitives. And we need to store, let's get a base direction, because we're going to do this basically by the facing angle. So our base direction will be 1 in x. And let's make an up vector as well to compare against. Which is just positive y. Okay. Now we need to get the angle that's facing compared to our base direction. We can get this with a cosine of the dot product. So this will be in radians, and it will also only be, this only gives you 180 degrees. So we need to do a couple more steps to get to calculate a full 360 angle. Okay, space direction compared to the normal. Yeah. This little expression is super handy, but it will only give you the shortest angle, so it won't tell you if it's over 180 degrees. It'll measure it back the other way. Okay, so now we need the sine of the dot product. And we need to get the dot product of our up, and then the cross product of our base direction and our normal. And if that's greater or equal to 0, then that'll be part of our first half. So this was just a Boolean essentially, but we can't do Booleans in Houdini and Vex because the first half of our circle. So angle equals first half. So we can just question that. And if it is, it just equals the angle. Otherwise we go 2 times and then pi, or, you know, that's enough. 4 decimal points is close enough, minus the angle. Then we go f at angle equals degrees, because because this is in radians. And then let's do our horizontal ID the same way we did our vertical. So I'll just do an int. I don't need to do a round to int with this one. Just do f at angle divided by 60. Let's copy this color node and change that to our horizontal ID. And you can see that that's working. Okay. Okay, let's come back to our clean really quick and just turn on a couple things. I don't want that though. Making sure we're fixing as much stuff as possible. And then I want a for each. Let's go named primitive. But instead of name, we want to do vert ID. So that should loop over each layer. And then let's do another loop inside of that. And this one is going to be our horizontal ID. So then that will do that. And then one final one for each connected piece. Inside of that. Okay. Okay, let's put down a fuse just to make sure. And this one, we're going to increase the SAM distance because we've already divided them up into their pieces. So we don't have to worry about bits getting connected together unnecessarily. Put down a UV unwrap. And the only thing we want to change on this is scale to none. And then I want a UV transform. And I'm going to put this to 0.05 because we're using a 20 unit high scale. So this is 1/20th the scale. So make it fit in one square. Okay, and then just come up here and grab these two. And slot that in there. So this works out our average UV. And then this will try and move it to back to square one. We want to do this in both directions though. Switch that over to Y and Y. Let's put down a quick shade. And see, it's done a pretty good job. There'll be areas that aren't perfect, but without building an extremely complex system, we're never going to get it perfect. Attribute promote, and that is just putting our part type to a point attribute. And that's this bit done. Let's start hooking these together with a merge.